Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, PIC, Ferrea Racing Components, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePowerTrade, the racing industry, every minute, every day. This is episode 449, and we're going to be talking safety in the world of EV racing. With me this morning are Brad Gilly, our wonderful host, and our co-founder, Judy Kin. So, Judy?
Thank you, Francisque, and thank you, everyone, for joining. I'm excited to have John Evans on again with ESI Equipment. He's working with great sanctioning bodies, great racetracks, and he just provides so many services and also products, safety products. So it's going to be interesting to learn more with John today and Ricard. So Brad?
Awesome. Thank you, Francis, and thank you, Judy. Really appreciate the opportunity to be a part of this, and we'll talk to you all here very shortly. Really looking forward to today's conversation, and if you've been watching our webinars for some time now, you've heard me say more than once that when it comes to racers, I've always told people that first money should be spent on safety, then you should worry about going faster. And I think that really holds true and should hold true throughout our racetracks and sanctioning bodies as well. Today, our topic, Advanced Safety Protocols and Strategic Planning in the World of EV Racing by ESI Equipment. And joining us as panelists are John K. Evans, the President and CEO of ESI Equipment, Inc. and ESI Racetrack Safety Services, and Ricard Johansson, Chief Safety Officer, the Swedish Automobile Sport Federation. So, gentlemen, welcome. And John, let me start with you first and just sort of help introduce the topic here today. Welcome back. It was a real pleasure to do this with you last year. And I know we got a lot of activity in the chat, which, by the way, you can always type a question into the chat as we go along with our webinar here today. But John, tell us a little bit about what we're going to be talking about today.
Sure. Last year, Brad, we kind of started to introduce what was happening out there in the field, and obviously EV racing is something that's peculiar, it's unusual, and for a lot of facilities, it became a big question, what do we do? And over the past year, we've been trying to get that message out of what do we have to do in order to protect our people, how to protect our track. And those are the kind of questions that we've been working on over the past year. So we're here today. I invited Ricard to come on board. We're both members of ICMS, International Council of Motorsport Science, and Ricard has done some talks during some of our meetings with ICMS, and he's got some knowledge that's happening overseas that may be most beneficial for us to know about. So it's really kind of let's bring some things together here to see what we can figure out.
And I know we have a short video to play here in just a moment, but Ricard, I just want to welcome you and say hello and thank you for being here as well.
Well, thank you for having me on.
Yeah, we appreciate that. So with that, let's go ahead and start with the video and sort of have a good jumping point as to what we're going to be talking about.
Take a look back at this. So this is Robin Larson comes over. Sorry, this is backward. Larson came over first and bicycled, as in two wheels. He got away with it, as you see.
But wait,
Andreas
there's more.
didn't. You know, watching the background, left of shot.
Oh, man. So, unfortunately, Andreas back route, and here comes Fraser McConnell, the pride of Jamaica, and it gets worse. The beauty of this is that they're okay. They are okay. The cars have seen better days. And we talked about, in the open, we're talking about last year and that big crash of Cabot Bigham. Watch this. Fortunately, he missed that wall, goes in the water. He lands on the Yokohamas. He's okay. Have you talked to Fraz? Have you talked to Andreas?
All right, a couple of pretty spectacular wrecks in the same corner right there. And Ricard, why don't you tell us a little bit about what we were looking at and how that relates to where we are today?
Yeah, this was from the first season of Nitrocross, where we run full EV cars, the FC1 car with over 1,000 horsepower, full EV. And that was two of the most spectacular crashes we had. I must say that when we investigated the cars afterwards, there were no damage to the drivetrains at all to those cars. They were fully intact. And you can see the last car, Fraser McConnell, he flipped 9 times and landed in a pond. So just to see how strong these cars are built, because a lot of people are very afraid of EV, that they're going to explode and they're going to happen just by looking angry at them. But that's not the case. They can withstand as much as a regular race car, if not even more.
Yeah, well, and again, I was actually expecting to see something, and when I didn't, it was, I think, probably more of a great pleasure as well. Let's just get an overview, the current state and status of EV racing. And John, Ricard, I don't know who wants to take that first, but where are we today?
I can talk about it on this side of the pond. We're still learning. That's part of it. Ricard has shown something that when there is a specific car built for EV racing, they tend to be a lot more solid and a lot more impermeable to damage, as he's just shown. But when we get other cars that are street cars that are now coming on to racetracks throughout the US and Canada, it's a different thing, because it's not, obviously the cars weren't designed for racing. And with speeds that they could potentially be at, there is a potential for problem. And we're learning, throughout the different series and throughout sanctioning bodies, how we're dealing with that. And we can go over that later.
Yeah, Ricard, what can you tell us about what's happening in Europe right now?
Well, I have had the opportunity to both do Europe and do Nitrocross in the US, so that's kind of good to see what is happening. And perhaps there is a reason why we have a lot of Scandinavian people going over and working with the EV series right now in the States, because if you look right behind me, you can see from the World Rallycross Championship. And I would say that right now, I would say almost all EV cars that are run in the championship are built and are run by Swedish teams. So I would say that we are pushing the agenda quite hard. Same for the FC1s. Everyone is built in Sweden. The same for the RX2E. So we have run the EVs for a couple of years, and I would say that Europe is running a few years earlier. And I think this is because of the auto industry that has pushed the agenda of EV more in Europe than you have pushed in North America. So I think you will see that, but you are running a few years behind in that case. And as John mentioned, I would like to say that we must make a big difference between the race car that is built, in this case, by the FIA spec, or the standard car that you take in on a track day, or that you want to convert to a race car. It's two totally different objects. One is really built for racing and one isn't it. So in that case, I think that is the main split we must do, that we have real race cars and then we have the road cars that want to come into the track. And I think that is going to be the hard part. The same thing where we run them. I don't see a problem running inside arenas, rallycross racing, drag racing, and so on. I see perhaps more of an issue running stage rally with them, for instance, where we run between big rocks, stone walls, trees, and so on. That will put a whole different type of risk towards the sport.
I think it's interesting that you talk about the difference between passenger cars and someone who might want to do a track day in a purpose-built race car, because, let's just take what is probably the most, most well-known, a Tesla, where the batteries are literally running the underside of the car. And a lot of people think about that. And especially as we watch the rally cars jumping and everything, that, almost takes you back a little bit. But when it comes to building an EV race car, Ricard, what can you tell us about the battery technology, where those are placed in the car, and what safety measures are taken in that regard?
They are still placed in the bottom of the car, but they are placed in a carbon fiber box that is almost 1 inch thick. So it's really, really heavy, really, really sturdy. So in comparison to a regular road car, perhaps that has a shell that is 3 millimeters of aluminium. So it's a big difference to be able to penetrate the battery pack. And then if we look at the surveillance systems, you have much more technology in a race car than you have in a regular road car. The tolerances are much smaller and so on. So you have more measurement of the cells in comparison to a road car. You have the tolerances are, I think, 5 times smaller when you're measuring resistance to see if there is an issue. You have the lighting system where you can see red and green lights on the car if there's an issue. You don't have that in a regular road car. So I would say that they are purpose built. And the road car is purpose built to be used on a regular road. So that is kind of the issue. To take a regular road car into the track will always be a compromise. It will be the same however we are running it. And what we see in Europe when we're running touring cars with EV, we just launched the Scandinavian Touring Car Championship this weekend, for instance. And what we see there is that you still need to do the modifications to get the safety into a regular car. So when you see regular shells, regular touring cars running in Europe, there aren't regular cars, they are race cars that are built in. So I think that is kind of what we need to think about. It's not the same when we're running combustion cars, because the engine is still the engine and then you put a roll cage in it. But this is a whole new type of technology we must take in consideration.
All right. Well, John, I'll tell you what, let's move forward a little bit now too, but look back, because last year you came on here and we talked a lot about EV safety, racetrack safety, where we were, preparedness, and all of that. So what can you tell us that we've learned in the past year?
Yes, obviously things change all the time. And, the good news is that we're starting to get a lot of partners in with us to develop either products or techniques or whatever it happens to be in order to start our mitigation process if there is an incident. So what we've learned is that obviously state of charge, the amount of charge that's in a battery system really gives a dependence on what kind of incident that you may have if something should happen. So anything below a 20% charge, the batteries really don't have enough energy in there to go what we call into thermal runaway. But obviously, as you start increasing that charge that's inside the battery, that changes its dynamics, and that dynamics results in thermal runaway potential, and that's what we're learning. We're also learning that there really just isn't one type of battery fire. What I mean by that is, yeah, you can have a thermal runaway, but you can also have an incident where the covering on the batteries are on fire, or something that's not generating the thermal type of BTUs that we get out of that. So that's what we're learning as well, is that it's not just one fire all the time, that we're getting different fires out there. Something that's been out there for a while, but it's come into vogue, is a blanket that covers a car. What we're seeing is that containing this vehicle may buy some time in order to get the car off a track or out of the way, so that we can deal with it someplace else in a different manner. So again, initial suppression that we look at, and then trying to cover the car with some of these blankets. We've learned, obviously, with the with the hurricanes in Florida, that the cars will burn underwater. All right, that's so obviously, if you're using water, it's not going to put the fire out. So if cars can burn in water, you're not going to put the fire out, and that's what we've learned. But we've had people come out with different nozzles that will be able to be placed under the battery compartments of the cars and cool the batteries down. And there's a number of manufacturers out there that will do that. Again, it still uses a lot of water that you probably don't typically have on a racetrack. The lowest that we're running at is 70 gallons per minute. And if you do that, some of these instances take an hour to 2 hours to actually cool down. You're talking anywhere between 5,000 and 10,000 gallons of water that you're still going to have to use and have available. And that may not be an option out there. We're also looking at, not just the large battery fires with lithium ion, but with all the auxiliary batteries that we have out there in the vehicles. A lot of different series are looking to change into the lithium ion. I know that there is one series that allowed lithium ion, and they had so many issues, they went back to lead acid batteries. So we're seeing that technology come into play, not just in the large battery packs, but also in the auxiliary batteries.
Well, that's interesting. And Ricard, maybe this is a good question for you as well. Now we start talking about racing facilities. A lot of racetracks inside of a fire truck, depending on what fuel is being run. When we start talking about internal combustion engines, maybe they have a dry powder or liquid extinguishers in there, or whatever it might be. But EV is a whole different ballgame, and that's just with when you have a fire and trying to put it out. But obviously, there are other concerns with the facilities themselves, and what do you do with something that is burning out of control? What can you tell us?
Yeah, the mindset you must have is that, as John mentioned, that we can come into a state where we can't put the fire out, and then we need to understand that either we take away the risk from the people or we take away the people from the risk. And depending on where we are on the track, are we far away at the bottom end, then it's not an issue. We don't have the risk with spectators and so on. But if we are in the front of the main grandstands, then perhaps we need to use the fire blanket to cover the car to be able to either pull it away or to get the spectators away, depending on what is easy. But we will come to a state where we set what we call light quarantine, which is an area where we take the car if it crashed, and we will investigate it. We will keep it under surveillance, but we won't take it into the paddock. We won't take it into the tent or so on. We need to have it separated. And then we have the area we call heavy quarantine, which is just a nice word for a place where you can let a car burn controlled in an environment where you have gravel or something. And that is the way you need to think about EV, that we will reach a state where we can put it out, because you will have heat, you will have energy, you will have oxygen, you have everything on the fire triangle inside the battery. And that is the big difference. The big difference is that if you have a combustion car, then you will have 10 or 20 liters of petrol, then it will burn out. But in this case, almost the entire energy is still in the battery, even though we used a lot of the energy in it, because it's the chemicals inside the battery that is an issue. So you can't just put a hole in the tank and let it flow out, and then you don't have the risk. So it's a new way of thinking. So we need to have more of a proactive thinking. Where is the wind going? How do we do it? Where do we have the teams? How do we do with charging? The series I worked with this weekend, they have an external charging point, so they don't charge inside the tent, for instance, to take away some of the risk. So that might be an option, or you need to have clear routines on how you do the charging inside the paddock, surveillance, when can you do it? You need to have rescue crew accessible when you do the charging. Are you allowed to charge with the wheel off? Do you need to put the wheels on? Stuff like that. You need to create your protocols for this as well. And I think in some way we have been we felt so comfortable about using the combustion cars because we're used to it. And now we need to change our mindset. Just one mindset that I think I thought about this weekend is that the teams are used to popping up the hood and starting doing all their mechanical work. And suddenly there is nothing there. So they need to work from the side of the cars to access the batteries, to access the engines and so on. And suddenly the entire pit layout becomes wrong because they're used to working in the front. And suddenly they need to work on the side and there's no space. So they start moving around their cabins and so on. So it's a new way of thinking. It's a new culture. And it takes a few years to set it, but when you set it, it's business as usual.
And how does this work too? Let's just say, you have a gasoline car, an internal combustion car. If a firefighter is going there to the scene, one of, if not the first thing that they're going to do when they get there is they're going to cut the main power switch in the car to make sure a fuel pump's not running, an engine's not running, or something like that. What does that do when it comes to EV technology? Does that necessarily stop anything from happening?
Not if it's inside the battery, then no, because even though you break the circuit, as you can do in many ways, but if you break the circuit, then you still have the battery is there. So you can try to not get electrocuted and not get it out of the battery in worst case, but the energy will still be in the battery. So that is kind of the big difference. Then I must say there has been a lot of cars burning up where the battery has been intact. So just by a car burning on the outside, it doesn't have to affect the battery. But if it's inside the battery and that is something that rarely has happened. So, but that's the big difference, that you can't cut off the fuel pump, because it's like you have an engine and you have the fuel tank inside the engine. That is the difference.
Yeah, for sure. John, last week we were here talking about hydrogen and alternative fuels. So, how about recent evolutions in EV and hydrogen technology in racing, and how these affect racing concerns?
Sure. I mean, if people know Extreme E is now going to be Extreme H coming up, they're totally changing over to a hydrogen technology. That's not something new. Hydrogen's been out there for a while. There are commercial vehicles that use hydrogen. I know about 15 years ago, we did a program with buses that were coming into an area that had hydrogen tanks on it. So when you start using a compressed gas system, there's a different type of dangers that are going to be inherent with that. And most of it has to do with the amount of pressure that you have. And when things start to burn, hydrogen does burn. When that starts to burn, it could release the gases too fast, or it could actually explode the tanks. We've seen that in a couple of different situations on trash trucks that use them. And just about a month ago in California, they had a truck that was a hydrogen powered, and the tanks blew up and injured several firefighters. So again, this is something new. We have to deal with it, and it's just the evolution of technology when it comes to what we have to consider as we start our investigation into how to handle these situations.
Yeah, it is interesting. Ricard, let's talk about European strategies with EV racing and event scheduling. What can you tell us?
Well, I think that this has been one of the issues, as I talked about at the ICMS conference, that in some way EV has run in different parts. You have the marketing department that is doing the real fast bullet train, and then you have the technical department that in some way has gone the little slower Amtrak train. And right now, in some case, you have safety going with the little cart you have to pedal yourself on that track, because marketing has been pushing EV quite hard and technical has been chasing, but we haven't really been in phase with the safety. And that is what we can see with the incidents we have had, and what we can learn from them, that perhaps we need to have better protocols on how we work around the cars. We are still in the culture of the combustion car, so we still try to do it the same way. And I think that is what is setting right now in Europe as well. I saw the new routines from the World RX for this year. They are very similar to the ones that we run in Nitrocross last year, with new charging routines. You need to have a strap connected. You need to have surveillance of the car when you charge and stuff like that. And I see that more and more you're seeing the risk, and you're going into having the real routines for these cars. So in some way, I would say that EV development has gone very far, but the safety hasn't been there. And this is typical of safety, because it's always reactive. Safety is always reactive. The only reason why we use safety in advance is to go faster. It's never to chase to be at the same phase. And it's the same thing here that we can see in all safety work. So
Yeah, for sure. John, how about North America with tracks developing SOGs and SOPs involving racing EVs?
Yeah, I mean, it's something that every facility needs to do. If they're going to allow any type of electric vehicle on their facility, they should have an SOG or SOPs that cover how they're going to handle the incident, what's going to happen after the incident, how they're going to mitigate this situation. What we're teaching tracks now is the biggest thing to worry about is damage to your track itself, the track surface, which can happen pretty quickly. So we've come up with packages with chains and J hooks, and that we can quickly grab a car and literally pull it off the track. We want to get it off of the racing surface so that it doesn't cause any more damage. Obviously, our first concern is the driver and making sure that the driver's safe. But we want to get that car off of the track as soon as possible. So, as part of this, we have to look at what happens with, the SOPs or the SOGs that you're going to develop. Where did they come from? How we developed them? Because as Ricard just said, it's all new. So we're developing these things as we go along. Now, groups like SCCA and NHRA have come up with their own type of rules and regulations regarding EVs and how they're going to handle them. But every track needs to also have their own standards and policies.
Yeah, it's interesting. Every racing series is different, which means every race track is going to be different in a lot of ways. And just in my world, I know IndyCar has a great traveling safety team, and they're very well in tune with their race cars. You talk about the NHRA safety safari. NASCAR has moved forward with a lot of what they do, having not just a traveling safety team, but also truly utilizing a lot of local firemen and women and safety personnel for a lot of that, and providing training for that too, with ACT training and different things. But when it comes to trying to standardize these things, and like you said, some standard operating procedures, and saying, hey, if you're going to have this, because it's not just a major sanctioning a body event at a racetrack, it could be, an SCCA autocross track rental that's happening out in the parking lot, or it could be something different where that sanctioning body isn't necessarily providing safety personnel, but they're relying on what the racetrack has also. So how do you get all of the tracks up to speed with what is the latest?
That's a really good question, and obviously that's what we do. We go out and we train tracks, and we give them a program telling them basically, this is how, if you call a fire department into your track, this is how they're going to handle the situation. Now, if you want to develop your own type of policies that are different than this, let's talk about them and see what's pertinent, and what kind of resources do you actually have on your track that can mitigate it differently. And again, as Ricard said, sometimes it's just letting these things burn out. After these cars burn out and the batteries burn out, the only thing you're left with is some molten aluminum and some carbon. And I'll tell you what, that's a lot easier to deal with that than trying to take away a live battery that's been burnt, and then trying to deal with that after the fact. And this is where I think a lot of tracks have to look at, okay, you may deal with the immediate situation, but what happens afterwards? Is the tow company going to be towing that car away? And can they? When will they? Um, if it's a small battery, such as an auxiliary battery that you have to take care of, who's going to take care of that after you've said, okay, we put it in an overpacked drum. All right, now what happens? There are several companies out there that will handle that, but you have to have those protocols and procedures in place before you say, we're going to handle this. And I was just saying that recently on a track where they didn't really know what to do after the fact. They contain the small auxiliary battery, but after that, they didn't know what they were going to do with the battery. So those are the kind of things that have to be developed. And again, as Ricard said, we're kind of catching up. A lot of people that would do recycling, there's a few out there that do recycling. There's people that will take this product it's a toxic product and deal with it after the fact. But again, we have to find out who those companies are and get that information out to all the facilities.
Mm-hmm. I just want to read a couple of comments from the chat. Tom Weisenbach says, John is the chair of the ICMS Racetrack Safety, our hands-on SFI certified hands-on training program committee. And Ricard was recently voted to our board of directors, and then gives the website. It's there in the chat anyway. Just some nice recognition for both of you. Will there be a Q&A session? Always, if you want to type a question into the chat, we'll ask as many as we can, and definitely we want to talk about what you want to hear about as well. And I do want to ask a couple of questions from here while we're talking about it. And one question is, do you see the use of a large capacity dunk tank to contain the EV fire? Ricard, maybe I'll let you take that. Do you think it's possible to have a big pool in the infield?
We have that in Europe. We have like the tanks you have back on the truck that you just put down, and then you put the car down in it. There's different versions. One when you use a crane to dump it, one when you pull it in and fill it with water afterwards. The only problem is that the water that will be inside a tank won't put the fire out. So the car will be in there and bubbling, And we can see this with the 12-volt batteries that has been in the thermal runway, where we put them in just a barrel of water. They will keep jumping for 2-3 days because it's so much energy in it. And you can imagine a car. The problem is that the water will be contaminated. So you need to take care of the water. And I know from back in Sweden that it would probably cost us around $6,000-7,000 at least just to have somebody take care of the contaminated water. So in that case, you must look at, is the better option to have it inside the tank and it will burn up inside the tank and you will have a shell and you will have contaminated water, or can we get it to a controlled place where it will just burn up and the gas and the smoke will go up in the atmosphere and you have billions of cubic meters of air that it will disperse in. So I think that we need to change our mindset that we don't have to put everything out. It's the same we do with house fires here as well. We just earlier we tried to save everything. Now let them burn because it's better for the environment. Just let them go up in the air in that case if you can't save them. And I think that is the mindset. If we could save the car, then it would be another issue. But right now, if you dunk a car down in water, it's destroyed. So, I think there is an option for it, but I don't know if it will really help us, and it will be super expensive with the contaminated water, at least here in Europe.
And that makes total sense. And I was actually wondering, on the one hand, there are a lot of environmental benefits to having EV racing, but on the other hand, when we start talking about this, how does this create new issues with it? There are two questions here, which I think are pretty similar. And if they're not, gentlemen, feel free to separate them. But one is, what about breathing apparatus needs? And the other one is, can you also comment on the PPE? Personal protection, and the latest video from BIC shared with ICMS.
Sure. I've been pushing respiratory protection on the racetrack for a while. It seems to be something that we just don't want to consider heavily, and maybe because it's infrequent that we have the issue. But there are standards out there for fighting a regular car fire that we don't follow on the track. And maybe I'm stepping on a lot of toes and opening up a big can of worms, but that's the truth. And what I've tried to develop over the years is at least something. And there are negative pressure masks that can be used with just filters on them. And there's some positive pressure PAPR systems that are very lightweight and easy to don. The issue becomes all the stuff that we wear, our headsets, our helmets, all these things that get in the way. And, at this point in time, not everything is compatible. So we're looking for maybe someone's listening that wants to take on this project and say, let's make something compatible to what we want to wear on the racetrack and having some type of respiratory protection. When it comes to our gear, listen, these cars or these batteries are burning at 4,000 degrees plus Fahrenheit. Our gear is not meant to handle that. So we can't be in the way of that. On the other side of that, neither is the driver's gear. The driver's gear is not meant to do that. So, as we were looking at ways to mitigate certain things, there's got to be some type of separation between the battery packs and the batteries and the driver. And the only thing that makes sense is a steel wall of some type. Now you can take that same theory and apply it to what Ricard was talking about back in the garages and saying we need to separate things and protect the thermal barrier so that we don't burn other things, whether it's people or other cars in the paddock area or whatever it happens to be.
There are a couple of questions here about fire extinguishers, and I do want to ask about that, or containment methods. And I know we've touched on a few things as well. Someone had asked about liquid nitrogen to cool down batteries once off the track. Is there anything like that? And I know, Ricardo, you've talked about you just have to let it burn sometimes. Are there anything that you can do like that to help
the
stop?
Problem, if we look at the physics, the problem is that you need to put so much energy into cooling it, and the battery will produce so much energy. You can imagine just a what a 12-volt battery will do. And now we're talking 900 volts battery that weighs 350 kilos. And you have, in some cars, you have double of those. There is so much energy in the batteries, so you will need to use so much energy to try to cool that battery down. So it's probably possible, but we don't have that amount of equipment out on a track in that case. So that is kind of the issue. And we have the fire inside the casing in the battery, so it will have good energy in there. We don't want to open it up. What we have is that we have a valve where we can flood the battery, but that will only work when we're in the early state, perhaps going towards a thermal runaway. If we are inside a thermal runaway, then you need to put so much energy, so much water on it to take away the energy. So it's almost impossible. That is why when you dunk it in a tank, then you have 100% containment of water. Then you can start getting some kind of effect, but you still won't put the fire out inside the battery. And that is the main purpose. I want to say that is when we have it inside the battery. Then if we have brakes that are going hot or some kind of that issue, then you just put it out as a regular fire. Then we don't have those issues. But if it's inside the battery, that is perhaps what you said, that in some way we are better towards the environment. But this is the problem if you're talking about synthetic fuel. We don't have the same emissions, but instead you need to use rubber gloves to work with it because it's not so good for your hands. So in some case, I would say all these type of technologies are the same, but we just put the danger and the risks on different positions. So in some case, it's better for the market. We get a lot of money towards the EV, but we have some other risks that we need to find to work around. Instead, we don't have risks that we have with combustion cars. So
I want to ask. Oh, I'm sorry. Go ahead, John.
Yeah, I just want to add on to that, Brad. Some of the partners that we're getting into this there are people out there develop some additive products, some foam products and other type of products that we'll be able to use for extinguishment. And some of them look promising, and I'll say that it's something that we have to we want to research with. The problem with researching it is it costs a lot of money. I mean, can't burn up a battery car every other day unless maybe Elon wants to donate some stuff, but it'll be nice if we can get there. The problem is there is no standardized testing right now. I don't know if there's any in Europe, Ricard. I don't think so, as far as it comes to battery cars and lithium ion batteries in cars. So there's claims out there, and you hope that the claims are great and they're going to be correct, but it's kind of a wait and see type of attitude that we have to start trying these on actual fires to see what's going to happen.
Yeah, that's interesting. Ricard, I want to ask you about this too, because so far we've just really talked about EV versus gas, but hybrid is a big thing right now. Whether it's sports car racing, IndyCar is now using hybrid. They're talking about it in NASCAR, and pretty much every series out there that might be a different answer. Now, for dealing with fuel and batteries, how do you deal with and manage that?
We have that in the World Rally Championship. We're running hybrid in the WRC1 class. So suddenly we have cars that are a little bit heavier because you need to have both the combustion engine and the EV drivetrain. It's a smaller EV drivetrain, it's a smaller battery, but you still have both the risks, and it's a little bit like it's not good to take two big risks and to mix them together. So in some case, it's that is kind of the issue we have right now. It's the same we're talking about hydrogen. In some way, it's a little bit like taking one risk and then suddenly adding a Hindenburg. In some case, it becomes hard to work with, and if we look at a crash with an EV car, then suddenly have a traffic accident. We can have an injured driver, and then we also have a hazmat accident that we need to think about. So in some way, we need to have that knowledge on how to work. I worked as a hazmat commander for almost a decade. So for me, it's quite kind of easy to think what I need to do. But if you work at a regular fire station and you don't have hazmat experience and hazmat equipment, then it's kind of hard to put on that layer as well. okay, where are the gases going? Where are the smoke? What's inside the smoke? How do I need to protect myself? And it's, as Jan mentioned, that we have routines for traffic accident. When I started out in the fire department 20 years ago, we almost never washed our turnout gear. It was cool to have a helmet. Our helmets were white, but they weren't white because it was cool when they were dark. And what we see after a few years, you understood the risk with cancer and started working with what was called healthy firefighters, and we moved to sand-colored turnout gears, so we can see if they were dirty, and we washed them after every call, and we started doing that. And I think that is the same thing here. We need to really look into our equipment. I always have extra turnout gear with me on the track, so if I'm exposed to a big fire, it can be a combustion engine and it can be an EV car, I will remove the clothes, I will wash them, I will take my extra gear. Not all tracks have that economical situation where they can have extra gear. We need to clean everything. Don't jump into a fire truck when it's done. If a driver has been exposed to it, he needs to go to the process as well. And that is kind of the issue we need to get into. And it's not only EV, it's also combustion if we have a big fire. But it's really important with EV because we have the hydrofluoride that is as dangerous to get to inhale as to get on your skin. And if you've been exposed, then you need to get off with your racing suit. You need to wash it. You need to get into the shower. You need to do that, and don't sit into the car. And the guys that are towing that car shouldn't just jump into the car without carrying. So what we do is that we have smaller fans we can work with. We have protective masks. We try not to get into the car. We try really looking at where we're placing ourselves. And these are the SOPs that are so important to have when we're talking about these cars. It's I would say it's not a different way of thinking, but we really need to start thinking because on the racetrack we have been a little bit cowboyish and just doing stuff. Not the way we did it at the fire department. So when I left the fire department, when I've done my shift and went to the racetrack, you became a little bit more cowboy. And I think that is what we need to change in mindset.
I don't think
Brad, that's just funny coming from a Swede. Okay, just so you
exactly
know.
what I was thinking. That's great. John, how about sanctioning bodies' responsibilities versus racetrack responsibilities? And if I could even maybe throw in a third to that, where do the insurance companies come into all of this as well?
Oh boy, yeah, sticky subjects there because obviously nobody wants to handle these. Nobody wants to be responsible for them, so they keep putting responsibility off to the people at the bottom. So I think every race facility has to ask that question up front, whether it's a sanctioning body or it's a club coming in or whatever it happens to be, who's going to be responsible for this and how far does their responsibility go? If it's if the sanctioning body comes back and says it's on you, being the track or the facility, then you better have the ability to come up with the solutions for that. And again, a lot of track facilities are not prepared for that. They're just not prepared to take that to the nth degree. I know Ricard was talking about some of those ideas, but when you take it for, and he's a hazmat guy, so he knows that there's the end game can be very difficult when it comes to disposal and things like that. So those are the things that the track has to come up with, and we at ESI are trying to help that through training and through courses that we're running as well.
A couple of things from the chat here. Dr. Deandra Leslie Pilecki, who's a friend, says if you're at all interested, then you should definitely join the ICMS to find out more about it. But a question in regard to ICMS as well: has ICMS come with a training class or any type of protocol for EVs on the track?
At this point, we have not. I mean, it's a big subject to handle. But during our annual Congress, I know that Ricard has presented there. And our last Congress that we did, we actually spent a half day on EV issues. And so there was a lot of information that was given, some studies that were done over in the UK that were very valuable as far as, pointing people in a different direction. And those are the kind of things that I think that, the ICMS can give. It gives you that worldwide view, and bringing people in that have maybe have done some research and development on their own. And that's very critical, because again, as Ricard said, it's new stuff to us. It's all new technology, and we're learning as we're stepping ahead. And there's some people that are really putting themselves out there for us and giving us some great information.
And I know we've covered a lot of ground, and it feels like we just started 5 minutes ago,
It does.
but we are running a little short on time. So, Ricard, I'll start with you and then ask you, John. I just want to make sure that we don't leave anything on the table here that maybe you did want to talk about and get through. Is there anything that we might have missed or anything you want to add?
I would say that now we've only been talking about the fire part, and that is what people mostly talk about. But what we have learned, what I've learned working with all the series I work with, is that the main issues we have had is logistical issues. They are really quiet in a paddock, which means that we need to have staff that works in front of them and clear a path, for instance. They are very powerful, which means that we need to to teach the drivers the importance of putting down the energy level. And you can do that on most cars. You can have from 1 to 10 in level. You need to put them down on level 1. Otherwise, you will have a car with 1,000 horsepower in the paddock that is that fast. And they are heavier, which means that towing is a little bit more advanced to do. You need to have perhaps different equipment. We have, for instance, the telehandlers. We have noticed that you can't have too small telehandlers. I know you love them in the US. We use wheel loaders, and for us, it's not an issue. But the telehandler can't really handle the weight, because they weigh 100, 200, 300, 400 kilos more than a regular race car does. So it's more logistical issues that we have learned that is the issue. And charging isn't always the hardest part, it's the cooling part, because you want to cool a battery, because a battery that is at the right temperature will give the right effect. And which means that the issue we have is the cooling time, not always the charging time. So I think that what we learn is that what we believe would be the most dangerous part hasn't been the real advanced issue to solve. It's more that you need to have the complete package. And of course, you need to have the SOPs in case of a fire, but there are so many questions before that you need to solve to be able to have them. And there is a community out. So I would say, if you are starting a new series, just get in contact with us, and we are happily able to share our knowledge and our SOPs and our routines, what we have learned, because there is no reason why everyone needs to invent the wheel themselves. That is really what I want to take with me and tell everyone that knowledge, try to share the knowledge, and it will go well.
Very well said. John, is there anything you'd like to add as we close up here?
Yeah, just one thing. I know that, we had talked about mitigating that battery or batteries that may be an issue. And there's a product out there that some major fire departments have been using for a little bit, and it's called cell block. And this cell block material can actually be used as an overpacking situation, where you put it in a drum and you put the cell block material in there, and will actually encapsulate the battery inside that. And I know that's been a little bit successful, and especially, in New York City, where they've had a tremendous amount of these small fires going on. And I know it's a big situation up there for them. So it's just something that's out there that can be used right away. And that's just one thing that I wanted to bring up. The other thing was that, we had to talk about, a facility and recharging infrastructure. I know Ricardo brought that up, but that's just another consideration that, each facility has to look at, and how are they going to handle recharging situations. If they bring 20 or 30 cars in, what's going to happen to that whole facility? Okay.
That's a great point. John, Ricard, this has just been a true pleasure. Great education as well. And again, we certainly probably could have spent 3 times as much talking about it, but hope to have both of you on here again. Thank you very much.
Thank you. Appreciate it.
Well, thank you very much, and great sessions. We pushed TSI's product back on the homepage of the ePortrait platform. This webinar has been recorded. It will be posted later on the ePortrait platform, distributed through our newsletters and social media channel. For more information and updates, please visit www.eportrait.com. Next webinar will be on sustainable fuels. So thank you once again, and goodbye.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePortrait really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.